Hello YouTube, SentinalhMC here for episode 17 of my ReactorCraft Tutorial Series. In the last episode, we talked about how to create deuterium and tritium. Now I'm going to show you a design for a reactor that you might use to create the tritium. This design was sent in by a subscriber, Kanethornwyrd. I don't know how to pronounce that, I just pronounced it how I think it's spelled. Put it in the description so you can see how it's actually spelled. And this is a 9-core fission reactor, which uses 4 neutron irradiation chambers. And I'm going to show you how to build it on screen. We're going to build it here because you guys said that you really liked it when I did that. So we'll do it again. So just find yourself an area. I'm in my reactor testing world, and I just happen to have these 6 turbines set up here with a different reactor. So I destroyed the reactor, and I'm going to build it here because I've already got these 6 turbines, which coincidentally is just how much you're probably going to need. Now I did test this reactor in the latest version of Minecraft 1.7.10 and it worked fine. We're going to build it now in 1.6.5. The differences between the two are there, but not too crazy. So we'll start off by placing whatever fuel core is going to be in the center, and make sure you have a good enough area around you in order to work. So what we're going to do is we're going to place down fuel cores, and we're going to place a steam boiler and then a fuel core. And then we'll probably just go over here, place a steam boiler and a fuel core. Okay, so what we're doing is we're going to surround all of our fuel cores are going to be surrounded with steam boilers on all 4 sides. So we start out with these 3, and then we're going to add 3 more in this direction, and 3 more in this direction. And there's your 9 fuel cores. Okay, so they're each separated by a boiler. Now, what this means, since there's no room in this reactor for control rods, what it means is that you're going to have to make sure that this thing will stay cool by itself, no worries. Just make sure it never runs out of water. Because if it does, there's no way to stop it. You'd have to go and take the fuel out. Come on. Okay. So there we have our basic structure. See that? You can pause the video here if you need to look at it. Alright? Okay, let's go. The next thing you want to do is you want to take a neutron irradiation chamber and just place one in the middle on each side. Make sure that you're going to be able to access the neutron irradiation chamber from the top as well as from the bottom. And in actuality, you should probably place these a space away from the steam boilers, because if you're going to be using liquid pipes from ReactorCraft, oh come on, then you're going to have to leave a space between these, because you're going to have one here and one here, and you don't want the 2 to connect, okay? If you're using a different kind of pipe where you can selectively choose to break connections, like I think you could do that with the liquid ducts from thermal expansion with our wrench, then you can put these right next to the steam boiler and shrink your footprint a little bit. But if you're using ReactorCraft pipes, liquid pipes, you need to space them out like that. So this is what you should have. Okay. Now this does reduce the power of the reactor for producing energy, but we're still going to be able to run all 6 of these turbines, so it's going to be fine. And now we need to place our neutron reflectors. And if you're running version 1.6.5, no, what am I saying? If you're still running version 1.6.5 of Minecraft, you're only going to need 1 of these, because they never let any neutrons through. In the latest versions, on 1.7.10, this is not true. You're going to need like 2 or 3. Kane had 3 of these on here, so you just line it up 1, 2, 3, 1, 2, 3. That's what Kane had, and then you have to put another blocks here to stop the particles, because some of them neutrons will still get through, and you can use a block of steel for that, or you can use some concrete. But you just want to place neutron reflectors on all of the cardinal directions from these fuel cores, because remember that the neutrons can only come out on the sides of the fuel cores, which is why you don't need neutron reflectors here, for example. You don't need anything there. Alright? And make sure you place your reflectors on the outside of the radiation chamber because you need to make sure that the neutrons can get to the radiation chamber. Alright, so we're ready to continue. Now we're basically going to just hook it all up. So just run your pipes. I actually like to do the we're gonna do the fuel for this with how I usually do it. We're gonna use a applied energetics system, and I'm just gonna place that probably here. So we'll place on a controller and a creative energy cell. This is just for demonstration. You can obviously use whatever system you prefer, and this is what was in there from my last thing. We're gonna grab some uranium. Fuel pellets, 2 stacks. I'm not going to put it in there yet. And then what I like to do, come on, let's grab a basic import bus. If you're using 1.7.10, obviously you're going to be using Applied Energetics 2, and so the way you set this up is going to be different, and we'll do a video on that later. Basic export bus, because in that there's only one type of import and export bus. So I'm going to place my export buses on top of my fuel cores. This is how we're going to put fuel into it. And of course you can use any type of item pipe that you prefer. Now we're going to grab some steam lines because we have to make sure we don't cover up the top of the boilers. So I like to place all of the steam lines just so that we can be sure that we don't do that. Steam lines. Steam lines. That's all the steam lines. Alright. So we will take some ME cable. In 1.7.10 this is called ME glass cable. And we're going to connect them all together. Nope. We don't need a pipe over there. I wish I didn't have to hold shift to do that, but I do. Alright. Place that there. Then we can connect these together. And we'll go this way and bring it over here. There. Plugged in. So these won't export anything because we haven't told them to export anything. Now we'll take our import buses and we'll put them on the bottom. Come on. Of all of the fuel cores. That. These. One more. And we'll go ahead and place our liquid pipes underneath all of our steam boilers. Well, we don't have to do that. Just make sure that we bring the ME cable down before we connect them together. That will ensure that we don't block off the steam boilers. See? Alright, so we got that connected, so we will just connect these up. And then we can run it this way. And up in control. Okay, so we've connected that up. Now we will finish connecting up our liquid pipes. Make sure we don't forget a single one because we need plenty of cooling. So this is why you have to make sure that you have either you have access underneath your reactor, or you'll want to place these pipes first and then place the blocks on top of them. This is totally an option. Okay, so now that we have that, we're just going to connect them all together. I like to connect the edges. first. And with the edges connected, we will go ahead and connect up the center bits. And that should result in every single one being connected. I'm pretty sure that's true. And yeah, okay. So I got that connected there. So next step is to supply us with some water. And I'm just going to do that by coming off over here, grabbing a, no, not a reservoir full of water. You can use ammonia for this, I'm pretty sure. I don't think these things will get hot enough to cause an issue using ammonia, and you will get more power out of it. So that can be a very good way to mitigate the power loss because of using these things here, is to use ammonia. Place our reservoir, we'll magic wand it so it's infinite. And now we can just go around and make sure all of our pipes are getting water. And yes, they are. And all of our steam boilers should now be full. There shouldn't be a single one that is not full. Plenty of water. Got it. Okay. Wait. No, that one's empty. Why is this one empty? No, I don't have a pipe under it. And this is why we always double check. Okay, don't assume you did it right the first time. Check it again. Make sure that it's right, because you don't want to have your boiler, your reactor exploding on you. That's never a good time. So just like I did with the liquid pipes, I'm just going to connect up the edges first, and then we can just connect up the middles. And now all of our boilers are connected together in this big grid. So what we're going to do now is we're going to connect the steam lines into the steam grates. So we'll just, come out from wherever is most convenient. It really doesn't matter. So we've got some up here. We'll put those together. These can be a little tricky to place sometimes because we got a small hitbox. Don't need that piece. Of course, this is not an ideal solution. I wouldn't have my turbines right up next to the reactor. I would probably have them in a separate room and run steam lines through there. But this is a demonstration, so all of our steam grates are now haphazardly connected to our reactor. We've got 6 turbines here. Okay, now we need to hook up our neutron irradiation chambers with some liquid. So what I'm going to do, I need to grab a reservoir, and there isn't one that you can pull out of this list with deuterium in it. Okay, so what I can do is search it, and we're going to use a I don't think I can use the fluid compression chamber for this because the pipes will explode. Now we can, because we have access to liquid ducts. Fluid ducts. Fluid duct from thermal inspection. I mean, if you're going to just, since you're going to be producing your deuterium and not trying to creative mode it in like I am, this won't be a problem. But you just want to hook. Now, if I can grab a screwdriver and it'll work. You just want to hook this up, and then it's easier just to give it a redstone signal, but there we go. We got deuterium in our irradiation chamber. I'm just going to do this for each one. So this is just the point where you would hook up your deuterium supply. So you're going to need, you know, a couple of... I don't know how much deuterium this is going to use per second, so I don't know how many electrolyzers and how many heavy water extractors you're going to need to run this. I haven't actually tested that, but you know, once you've set up something like this, then these things you don't have to worry about exploding. If you run out of deuterium in these, it's no problem, because you know, just put more in until it's constant. That's really not going to affect anything. You're still going to have a reactor running that's producing 6 turbines worth of power. There we go. So we've got deuterium in all of these. Now we're going to take our liquid pipes and we're going to connect to the bottom, because the tritium comes out the bottom. Don't forget that. And I'm just going to come around the outside. And we're going to connect our tritium outputs together. I'm going to have to go... I'll just go... I have to go around this one. Because again, I don't want these to connect. I can actually use... isn't that what this is for? I think what you can do with bypass pipes is... Come on. Oh no, they can't connect straight to the reservoirs. Anyway, we'll worry about that later. So we'll just plug that together. It's kind of funky how I had to do that, but you know, you can make your designs much better than this as far as laying out pipes and things. So we're going to connect all of these together. I didn't actually have to even go that way. Oops, we have accidentally connected to a water supply. Unfortunately, because I connected it to the water supply, I now have to destroy all of these pipes. And I don't have to, but I could get it to pump out, but I'm not going to do that. So do be careful that you don't get water in your... Obviously, if you're just setting this up, you probably lay all the pipe down before you put the water into the system, so you wouldn't have that problem I just had. Okay. Hook this up. There. That's all 4 of them hooked up. We can avoid this corner over here. And then we'll just go ahead and put some sort of tank over here. I guess we'll build a ReactorCraft tank. No, there's got to be a better way to do it. Let's just use an open box tank. Dynamic liquid tanks. I don't really care. We'll just take any old tank and connect it up. There we go. So we got a tank here connected to our tritium, so we'll see the tritium coming in. Now this is all set up, and it should work. Okay, so we don't need to tell the basic import buses what to import. That's not a thing. They'll just import all the spent fuel and all of the waste. But we're going to tell the export buses to export fresh uranium fuel pellets. Just make sure you don't actually put the uranium into the ME system. Or if you're connecting this up to an existing ME network in your base, make sure you don't do this step until last, like I am. Because it'll start to fire up. Alright, so we've got uranium in all of these. Now we're going to go ahead and throw our uranium pellets into here. They're going to go into the reactor. And they're going to start to heat up. And they're going to heat up our steam boilers. Now you're going to be able to see the neutrons flying right here. See that? And right there, the little blue balls. And they're hitting the radiation chambers, and we've already got tritium in the system. Now I've got all these turned off. So let's go ahead and turn these on. So like I said, you should be able to comfortably run 6 turbines off this reactor while producing tritium. And if we look at this, we can see how much tritium we're producing. It's going up. Kanethornwyrd estimated the tritium production at, I think he said 140 millibuckets a second? No. I forget what he said. He estimated that. But as we can see here, we are producing tritium. And once these get up to speed, we'll be able to see that we can run these turbines at full speed. Which is fantastic. You can see the little neutrons shooting through there. Now it's incredibly important, since we have that gap, and you can see these neutrons here, that you never touch, never walk in between those. Please do not. Because if you do that, you will, and you get hit by a neutron, it's not going to be a good day for you. That is a very bad thing to have happen. Don't let that happen to you. So we're getting up there, and these are almost at full capacity for running on water. Obviously, if you ran it on ammonia, that would be twice as high. You have double the torque with ammonia. There, that one's at full power. That one's at full power. That one's at full power. It'll fluctuate around. In 1.710, there is a turbine flywheel that you can use. Let's talk about that at a later date. So there we go. We've got 6 turbines running. We are producing tritium. We have produced 1,450 some millibuckets since I flipped it on. Obviously, there is also some in the tanks here, the pipe. And the tritium production is pretty on point here. As you can see, the amount of tritium in this irradiation chamber is not hitting 0. Remember that the actual tritium production is actually random, because it's based on neutrons randomly being ejected from the reactor and hitting them. Ooh, that one's getting quite full, actually. And so if a whole bunch of neutrons hit it in succession, you're going to get quite a lot of tritium produced. But if few neutrons hit it, you're going to get less produced. So what this means is that whenever you're building a reactor that you're going to be putting these on, you want to try and make sure that there are a good number of neutron events that are likely to go in the direction of your irradiation chamber, which is why a design like that, like a linear one, the linear design, where if the neutrons fire in either of 2 directions, they're guaranteed to hit the chambers, is a pretty good idea. Or like a design like this, where you got 1, 2, and you've got 3 that are, if they produce one. What you end up with is you want to try and make sure that it's very likely that neutrons will hit your irradiation chambers, is what I'm trying to say. You want a reactor that produces a lot of neutrons. There we go. There's also been speculation. I've seen some speculation that uranium produces better tritium faster than running it on plutonium. I haven't personally tested any of that, and we'll see what Reika has to say about it. Maybe it's true. But we've got now 3,400 millibuckets of tritium in the tank. There's another 500 in 2 of the things. So as you can see, it's not difficult to produce tritium. It's not difficult to create a reactor to produce tritium. Just come up with your designs, and you really can't go wrong, except like, remember in my example where I was, when I showed this to you, when I had the linear reactor. A linear reactor like that, where it's just one line of fuel cores, you're best off putting the irradiation chambers on the end. Like, just put 2 of them, one on each end, because putting them on the sides would have no purpose, because there was only one fuel core that could have fired one in that direction, so it's a lot less likely that the neutron is going to go that way. Whereas if you have 6 cores lined up and you've got them on the ends, then at any moment you've got 6 fuel cores that are firing neutrons. It means it's very likely that neutrons will hit it. So just keep that in mind when you're placing these irradiation chambers. You want to place it in a place where it's very, very likely that lots of neutrons are going to hit it. Because this is not the kind of machine that has a progress meter that's just going to keep going up at a set speed. It's all based on how often neutrons hit it. So, which is why someone was talking about using a fusion reactor. I'm sure you could place these in at a fusion reactor, but because there's a lot, people were suggesting that it might not be all that good because the fusion events take place, all over the thing. Basically, you need to make sure that your neutrons are actually going to hit your irradiation chamber. You also don't want to put the irradiation chamber in a place where it's going to block the reaction. So I would not have put this irradiation chamber right in the middle of the reactor because I believe it absorbs the neutrons that hit it. So if you put it in the middle here, it would act as a retardant between these two reacting. So I've decided to put them there. So I hope you enjoyed the video. I hope this has given you a bit more information about the irradiation chamber, and that you can now go and build this reactor if you want, or come up with your own designs. But yeah, it's not difficult to set these things up to produce tritium, and you can make a reactor that can produce both tritium and a good amount of power, because nobody can argue that this is not a nice amount of power. Obviously, without these chambers, you could probably run more turbines off this reactor, but if your goal is fusion, you're going to have to, you're working to get working it up so you can get your power from that rather than from these nuclear reactors. So, I hope you enjoyed the video. Stay tuned for future videos. I'm SentinalH, and I'm signing out.